Good afternoon, people. 4 p.m., April 20th. So, our last class together before test and in this semester. Okay, so just two of you. Okay, so two then two. Any questions before I start whatever I prepared? Maybe you have something specific you want to ask me about course, about any material that we had. Guys, yes, no, please respond, say something.
Yeah, I'm here. I hear
Sorry?
your voice. Yeah.
Yes. Yes, I didn't hear what did you say.
Oh, yeah, I'm saying present. I hear your voice. I can hear your voice.
Oh, okay, very good, very good. So if no questions, let's start. So the Clarkton Guitar Company has set a target to sell 1,500 units from its new guitar line this year for a suggested retail price of $479 per unit. Company has estimated that a fixed cost then can be attributed to this new line is 3,000 per month. The manager also estimates that the variable cost per unit is 190. So, question: do we have units here? Yes or no? Yes, we have units. So let's answer questions one by one. Calculate break-even volume for year. So here we have a little trick. 3,000 per month, right? And 1,500 this year. So what we have to do first, we have to find fixed cost per year. So 12 times 3,000 is what, 36,000, right? That's what has to be done. Now contribution margin, that is 479, which is the price, minus 190. Where's my calculator? Okay, 479 minus 190 to 89. Okay, now I can say that break-even point in units, it is fixed cost, which is 36,000 over 289. Okay, and that is 124, 5, 6, 7, and then that's it. So I can say around 125, around that. So that number of guitars what we're supposed to sell per year in order to break even. That's actually a pretty good number. If company can produce up to 2,000 units per year, config break-even point as a percent of capacity. So changing 1,500 to 2,000 not gonna change those calculations what we just did, right? So what we have to do to break-even point as a percent of capacity, we just take break-even point what we calculated over 2,000. So let's see, 0.0625 or 6.25%. It's pretty good business, guys. Of course, if you sell everything what you want to sell. How much profit will Clapton Guitar Company earns if it achieves its target sales? So profit. What profit is this? Total revenue. And target sales is 1500 units, right? So 479 times 1500. Okay. Minus total cost. And total cost, that is variable cost, which is 190 times 1500 plus 36,000. Right? So what is that? Profit, can continue like that, 479 times 15,100, sorry, 718,500 minus 288,600. So the difference is 429,900. Let me double check. For some reason it didn't work. Yeah, that's what it is. So profit. If average only 100 units are sold each month, how much profit will the company realize during this year? So we can do average 100. So it will be, we will have same calculations, except 1500 we will have 1200. 1200 minus 190 times 1200 plus 36,000. So profit will be 479 times 1200, 574,800 minus 264,000. So and that is 310,800. Okay. Describe the impact on expected profit if only 100 units are sold each month. Okay, so what impact? So we can find the difference between this amount and that amount. So we can say that if we sell 100 units each month, we will realize less profit, and delta profit is a difference, right? 429,900 minus 310,800. So what is that? That is $119 and $1,000. So that is the difference in profit when we sell only 100 units per month. That's it. Any questions? Okay, do you want the chart, people? Yes, what's up? Okay, if you have another number. Okay, let me double check. Okay, let me double check. 479 times 15. I have gremlins sometimes, you remember, right? 190 times 1500 plus 36,000. Oh yeah, right. Yeah, you're right. This and that and that. So for some reason, I don't know, maybe I didn't press like this, right? That's what you have. $397,500. Let me double check. Yes. 718,500. 397,500. So what about this one? 190 times 1200 plus 1064. Okay, this one is good. Okay. Okay. 310,800. This number is fine. And what about 397,500? 86,700. So I have these numbers. Double check your calculations now. Maybe you got gremlins as well. So now we okay? Okay, let's continue then. So it was units. Okay. Consider following data and provide breakdown analysis. We have sales revenue, fixed cost, variable cost, capacity. So do we have units here, yes or no? No units. Okay, so we could incorporate formulas for no units case. Contribution margin, it's a 600,000 minus 270,000, right? So what is it? 330,000. Contribution rate, that is contribution margin, right? Contribution rate, that is 330,000 over 600. So let's see. 0.55. Now break-even point in dollars, it is fixed cost 275,000 over 0.55. It's a $500,000. As a percent of capacity, that is $500,000 over 800. So what is that? 0.625. Okay. Determine break-even volume in dollars. The fixed cost increased by 40,000, while variable cost held to 40% of sales. So fixed cost 275,000 plus 40,000. So what is that? 275 plus 40, 315,000. Variable cost is 0.4 times 600,000. Okay, that is 240,000. Now, by changing variable cost, we affected contribution margin, contribution rate. So contribution margin is 600,000 minus 240,000, 360,000. Contribution rate, that's 360 over 600, it should be 60%. Okay, yes it is. And finally, break-even point in dollars, that is 315,000 divided on 0.6. So 525. That's it. Questions? Okay. What total amount must be remitted if the following invoices returned for 10 to 39.60 is paid on May 10? So I highly recommend to make a picture. March 21. So here I put 850 and 1 minus 02, 1 minus 01. Okay. So let's calculate cutoff days. So first cutoff day, it's 10 days after March 21. So what I have, March 21, that is 80 plus 10, 90, so March 31st. March 31st. Then second date, 30 days, we still start from March 21. So March 21, 80. Oh, actually, yeah, it's 110. So it is April 20th, right? April 20th. Where do I pay? I pay here on May 10th. So I'm not allowed any more discounts. So 08 times 09 times 850, $612. That's the amount what has to be paid on the first invoice. So let's do the second invoice. So I have April 20th, 960, 1 minus 03, 1 minus 016 in period. Oh, not 20th, April 10. April 10. So 10 days. First cutoff date. April 10 gives me 100, so 110 is April 20th. April 20th. So second one, April 20th, 110 plus 20, 130, and I have May 10. So May 10, and it's happened to be what? Payment day. So it is last day for 2% of the discount. So I multiplied that on 002. So let's calculate. So 1 minus 0, okay, times 0.98 times 960. So 548.80. That is second month, second invoice. So let's see for the third one, April 30th. I have 1040, 1 minus 0.3 in period, right? 1 minus 0.25, 1 minus 0.05. So what is the first cutoff date? 10 days, April 30th. Let's see, April 30th gives me 120 plus 10 is 130, and it is May 10. So May 10, and that happened to be last day of 4% of the discount. So I apply extra 4%. Let me recalculate because we have unexpectedly low number. Yeah, 474.24. So that is. And finally, what we add those three highlighted numbers together. So plus 548.80 plus 612. So 1,635 and 4 cents. So that is the final answer. Questions? Let me know when you're ready to continue. Okay, next. Retailer buys an appliance for $14.80 less 25 and 15. The store price members merchandise regular selling price to cover expenses 40% of regular selling price and net profit 10% of regular selling price. During the clearance sale, the appliance was sold at markdown 45%. What was operating profit or loss? So first of all, let's find cost. So how much they pay for that? So 0.75 times 0.85 times 1480, 943.50. That's how much they pay. Now expense is 0.4 from S. Profit is 0.1 from S. Now we can create an equation. So S is 943.50 plus 0.4S plus 0.1S. From here, S, let me calculate, that's 1887. Now we create sale event and sale price is 1887, 1 minus 0.45. 1037.85, that's the sale. Now profit. Profit will be a what? Difference, total revenue minus total cost. Total revenue is 1037.85 minus 943.50. And let me calculate somewhere here. Let me take bright color. So 0.4 times 1887. 1887 times 0.4, 754.80. Right? Well, yes, it's supposed to be more clear than that. So 754.80. So that's expense. Now this expense I subtract from here, and most likely I will have beautiful loss, right? And indeed, 9 minus 660.45. That's it. Questions? So let me know when you're ready to continue. Okay. Merchant bought some goods at discount 25 list price. Well, that's the pure algebra. Uh, okay. You want to do it, or we can skip on that? This kind of questions you're not going to get. I don't know why I put here, so let's skip it. Scheduled payment 800 due 2 months ago and 1200 due in 1 month are to be repaid by payment 2000 today and balance in 3 months. What is the amount of the final payment if interest that such and such? So let's have 2 months 800. Now 1 month 1200. So instead of that we pay 1000 today and 3 months balance. So focal date now. That's the focal date. So let's calculate agreements separate. So agreement 1 is 800. 1 plus 0.0775. 2 over 12 plus 1200. 1 plus 0.0775. 1 over 12 negative 1. So agreement 1, let's calculate. So 8, 10, 33 plus 1192 30. So 8, 10, 33 plus 1192 30. $2,002.63. That's agreement 1. Now same kind of calculations for agreement 2. $1,000 is there plus X times plus 0.0775. 3 over 12 negative 1. So $1,000 plus 12 times 0.98 099 3256x. So okay. Now I create equation. And equation is following 2002.63 equals 1000 plus 0.9809326 times x. So x from here, let me calculate. $1,022.06. That is the answer. Any questions? Well, first of all, we have guidelines about how to choose the focal date. If it was not specified here, I would choose focal date 3 months. Okay, so it's either. So if you have one unknown payment, we choose focal date of the unknown payment. Right, second guideline. If you have more than one unknown payment, we choose focal date now. And third guideline, they say what date they want to use as a focal date. For instance, they say now, right? So we use it. That's it. And regarding future present value, you just compare direction where you go with direction of time. Time flies from left to right, so if 800 goes same direction, we use future value for them. 1200 goes opposite direction, right? So we use present value for it. All values must go to focal date. So you just put arrows on a diagram and see where they're pointing. Okay? Was it good enough? Okay, so no answer.
Yes, I have. I get this now, but sometimes in the problem, it's not clear if they are talking about the amount that was lent or the amount he's going to pay in the future. That with plus interest. So in those cases, I don't know if I have to see if that on the due or off, of it's a off or a for. Like many
So
times.
do you have specific question? We can have a look.
Yes. Okay. Let me. We have an exercise that we have
So
problem
find
with.
me question, give me page and question number. We will have a look on it. Okay.
This is from the quiz. So, but I can tell you the problem.
Okay. So whenever you're ready, you let me know. In the meantime, we can continue. Do you mind?
Okay.
Because we have lots of stuff to do. So as soon as you find the problem, ask me that question, and we will come back and solve it. So loan payment of 700 due 3 months ago and 1,000 due today are to be paid by payment 800 in 2 months and final payment in 5 months. If 9% interest is allowed, the focal date is now what is the amount of the final payment. So let's do, so 3 months, 700, now $1,000. And we have 2 months, 800, 5 months, final payment. Again, they want final payment focal date now. Right, so both agreements, they have more than one payment, so I find useful to calculate them separate. Okay, 3 over 12 plus 1,000. 1,000 stays as is, it's already the focal date. So 715, 75, 171575. So that's agreement 1. So let's do agreement 2. That's 800, 009, and here I have 2 over 12 negative 1 plus x, 1 plus 0.09, 5 over 12 negative 1. So A2 is 788.18 plus x. Well, actually, let me do this. Okay, plus, let me put coefficient first. And guys, I just remind you that I memorized those coefficients into my calculator's memory, so I later just recall them. Oops, wrong button. So now we can create equation 171575 equals to 788.18 plus 0.96385 5422 times x. So x will be, let's calculate. $962.35. That is the answer. That is the answer. Okay, if it's difficult for you to find that specific question, wait till we have a break, and then you find it and let me know. Okay, next. A loan of 3320 is to be repaid by 3 equal payments due 92, 325, 235, and 326 days. Determine the amount, focal date today. So now 3320 we have payments. We have payments 92 days. Well, use, guys, minimum 6. If you use all, specifically if you memorize results to the calculator, it's not. And again, if you have few pennies difference between your answer and test, I go through each test and I analyze what is it. If it is the case, I just update the mark. That's it. So don't worry about it. If it's the difference, it will be very minimal. So here, our focal date today, we have, in this case, one amount in first agreement, which is loan amount. So we can create equation right on the spot. So 1 plus 0.0875, 92 over 365, negative 1 plus x, 1 plus 0.0875, 235 over 365, negative 1 plus x, 1 plus 0.0875, 326 over 365, negative 1. So 3320 equals, so let's calculate. It is 0.978421123x plus. One more time, and I remind you that I memorize those values, those coefficients into calculator. So I don't have to rekey it back. So 0, 2, 5, 1, 4, 1, 3, 5, x. So 3320. Now I add them up. 2.85. You see how fast it was? Because I just recalled value one after another, having the last one on the screen. Oh, it's 86 here. So from here, x will be 1163.85. That is the final answer. Let me know when you're ready to continue. Okay. Calculate the present value of non-interest bearing 7 months promissory note for 1800 dated August 7, 2021 on December 20, 2021 if money then was 9%. So non-interest bearing note August 7, 2021, that's what issue date. 7 months, 7, yeah. So 1800 sits here. And they want us to calculate December 20th, 2021. So basically what has to be done this. But before, we need to find actual due date, right? Because we need number of days for our calculation. So what is 7 months? August 7, so I have September, October, November, December, January, February, March. So March 7, 2022. And now we have to find this T, right? So T is, so what we do, 365 minus December 20th. December 20th, 354. Okay, plus March 27. Is March 7. Is 2022 leap year, people? Yes, no? Guys, is 2022 leap year? Oh, yeah, right. Why you say so? Can you prove it? Okay, divide by 4, 2022. Divide by 4, you have 505.5. So, 05. So it means it's no leap year. So we don't care about February. And therefore, P is what, 1800. 1 plus 0.09, 77 over 365. And what is it? Minus 1. 1766.46. That is the answer. Okay. So let me know when you're ready to move forward. Okay, I guess we can go. 180 day note dated September 14, 2021. Okay. So note dated September 2021 made 5% for 1665. What is the present value of the note on October 18 if money is worth is 6%? So this time we have interest bearing note. Let's make a picture. So September 14, 2021, and I have 1665 sitting right there, and 180 days. So I don't need maturity date because I already know number of days, right? So 5% interest rate. Now, and what we need to find, October 18, 2021, and here we have 6%. So first step, I would say we need to find maturity value. So first step, 1665, 5% interest to use, 180 over 365. So what is it? 1706.05. So this value is here. Now we need to take it back, right, to this location. In order to find that value, I need this time t. In order to find time t, I need this time t. So let's start with the green one first. So t is, so October 18, September 14. October 18 gives me 291. 291 minus September 14 gives me 257. Okay, 291 minus 257, I have 34 days. So, and then purple, or whatever color it is, T is 180 minus 34. What is it? It's 146. And finally, we can create second step, which is 1706.05. We're taking back in time using 6% and 146 days. And what is it? I found 1666.06. That's it. Questions? Okay, guys, I think let's have a break. So, let's be back at 5. Back at 5. Oh, and we have question. Loan due 5 years. Okay, so we'll do that after the break. Okay? So break, guys. Okay, guys, here we have two questions. Chris, your question is out of scope of this course, so we didn't take bonds, right? We didn't learn bonds, so we're not gonna touch that. But for Maurizio, right? If I say it right, let me show you. Let me pick up page. Let's say this one. So for a loan is due in 5. Oops, wrong 2. So we have now, we have 5 years. So that's why I say put those pictures. So 4900 sits there. Of course, if you stay now, it includes interest, right? So we have compounded annual interest rate, right? Let me color code it. So for the first one, for the A, find the equivalent payment that settle the debt at the following time. Now, so we take here, it means time from left to right. We go opposite with present value. So present value, that's compound interest already, right? So 4900, 1 plus what is it? 34 compounded annually, 0.034, negative 5. So let me calculate it. Times 4900. So 414565 You actually don't need focal date because you have specific task. You need money. You have money in one location, you need it in different location. That's it. So in 2 years. 2 years, so what you do, you take it here, and B, present value, it is 4900, 1.034 minus 3. Why 3? Because this is what 3 years interval, right? 4432, 35. And in 5 years, C, it will be the same amount, 4900. That's it. Okay. Okay, so let's continue. You're welcome. So where we are. Okay. All right. So investor purchased 100,000 T-bill on issue date. It yielded this and that. Investor held T-bill for this 67 days, and then it sold it for this much. So let's make a picture. So a T-bill is what? Non-interest bearing promissory note. So it means face value sits in the future. Then 385% here, and we have what, 67 days, and at that point we sell for 98,853.84. So he bought it, he sold it, end of the story. So let's do one by one. And for T-bills, we remember we have two formulas, formula for P and formula for R. That's it. No future values, nothing. Another assumption we make, so every new owner, we assume that it will hold T-bill to the end of the game. So it means future value for every new owner is $100,000 in this case. So yield, R, original price, P. So 100,000 1 plus 0.0385, 182 over 365, negative 1. So let's calculate. So $98,116.43. That's how much this gentleman or whatever lady, investor, paid for that today. So question 2. Question 2 says what the yield. So whoever bought this on 67 days later, we assume that this new owner will hold it to the end of the game. It means future value. It is face value, right? 84, 988, 5384. And here I have, let me calculate that separate. This T equals to what? 182 minus 67, 115 days, right? So 115, 365. So let me calculate. Three six seven nine 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 08, so approximately 3.68%. Okay, so let me know when you're ready to flip a page. Now, rate of return. Rate of return for that guy, original, right? So he purchased that for 9,816. He sold it for 98,853. So it means 98,853 is his future value. 98,116 is his present value. And therefore, return on investment. So future value, 98,853. We don't have to assume anything in this case because what? Because we already have a transaction, complete transaction. Actually, complete investment. Right? And this game was during 67 days. So let's see. Zero 0.0409 43536. So approximately 4.094%. And again, depends on accuracy. We need to. Questions? So let me know when we can continue. Okay, next. Construct complete payment schedule, including totaling. Oh, okay, so that's amortization table. Let's do it. So number, balance before payment. I find this column completely useless. I put it only because you will have that on your test. And then payment itself, then interest calculated, principal calculated, balance after payment. Oops. Okay. So how many payments, guys? Any ideas? So interest is PRT, right? So RT which is 0.065, 1/12. This thing will be calculated every and each time. So I put it I, and I calculated well, it's not nice convenient number, but I use calculator's memory, so I don't care. Or you can actually do this calculation every time. It's up to you. So you didn't answer my question. How many payments I can expect here, guys? Okay, so let's pretend we don't know. Let's see how in this case it's possible to do. So 5,000 here. I will show you calculation for one line, and rest are the same except the last line. So we will solve first and last line together. So balance before payment $5,000. Payment is $800. Interest. So interest, first line, interest amount is 5,000 times I. So times 5,000, 2708. So I come back, 2708. Right. Principal. Principal is payment minus interest. I just calculate basically what's happening. I'm paying my interest amount. Right? 772.92. So 772.92. And balance after payment, I take previous balance or balance before payment minus principal, what I just paid. And it's 4227.08. So 4227.08. Let's do the second line. So 4227.08 travels here. 800 times equals 0, 2290. And right away I analyze those two values, right? So 2708, 2290, interest goes down. That's the way it's supposed to be. Now, principal is 77710. Again, principal goes up. That's the way it's supposed to be. And balance, of course, decreases because that's why we pay. Okay, line 3. So 3449.98, 800. So 1869. $781.31. That's 2668.67. Let me check something. Okay, good. So 2667.8, actually 67. 2668.67 times 4. So 800 payment, 1446. So 800 minus 1446, 785. Wait a minute, what's happening? Okay, 1446. Good. Okay, 785. 54. So 1883, and I observe those numbers. So interest drops, principal grows, everything going well. 883.13, 800, 1020, 789.80, 1093.33. So line 6, 1093.33, 800, 592, 794.08, 304.25. And at this point, I see that my balance before payment is way less than what? Than my payment amount. Yes? So I have to adjust the payment. So I start from setting balance after payment to 0. So line 7, balance after payment, so I set 0. Principal has to be the same as balance before payment, right? 304.25. Then interest has to be calculated times I, so 165, 165. And payment finally, that is 165 plus 304.25. So 165 plus 304.25 is 305.90. 305.90. So therefore, question has 7 payments. How is possible to analyze prior to building a table? We just take amount of the loan and we divide on 800. So let's do this. What's happened? It's 625. So 6 full payments of 800 and last payment is adjusted. So 7 payments. Understood, guys? Now regarding totaling, so 800 times 6 plus 305.90, that's $5,105.90. Wow, it's really I cannot see that. So which color is bright enough? Maybe let's try black. $5,105.90. So let's add interest together. Something's wrong. 2708 plus 90 plus 1869 plus 1846, 1020 plus 165. Somewhere we made a boo-boo. It doesn't match. So let me, how do I like it? 270, 2708. Okay. 772. 708. Okay, let me quickly. Okay, 98 times 3.0, 69. Okay, plus 7. Okay, 1446. 785.54. 13. Okay. 1020. 789.80. So far, we're doing good. 592. Oh, I know where I made a mistake. 1093.33. Here, I read it as 8. That's why. Oops. So, things got on the last step. We found the booba. So let's fix that booba. So pen, blue. So 1093. Let me put 3 here. So you see how critical and important this totaling. $92. 800 minus 592. This one is good. Otherwise, we wouldn't catch a mistake. So now we have 299.25, right? So 0, 299.25. This goes away. Algorithm is the same, just numbers are different. 299.25, and then interest 299.25 times I, 162, and payment 162 plus 299.25. So 1 plus 299.25 is 387 cents. So 162, 387. Okay, now we total again. So 800 times 6 plus 300.87. I have 5,187 cents. Now I total interest. I have 187, so it is promising, you see. And if I total principal, I should receive 5,000, right? And I have 5,000. So those three, they match. If I take payment total minus interest total, I have principal total, which matching amount I borrowed. That's the way it's supposed to be. Any questions? So let me know when you're ready. I still have lots of stuff to do. case we didn't do something, you can look up on different classes because we did similar questions many times. Okay, can we continue, people? Okay, so 5 years after Anne deposited 3,600 in the savings account that earns interest 4.8 compounded monthly, the rate of interest was changed to 6 compounded semi-annually. How much was the account 12 years after the deposit was made? So we have now 3,600. We have, what was it? 5 years. We have J12, 4.8%, right? And we have 12 years, and J2, 6%. Let me do this. Blue, and what? Let's say this color. So let me use respective colors. So first we find future value. What is 4.8 monthly? 1.004. 5 years, 12 times is 60. So 4,574, 31. Right? So this amount is here. So step 2, we take value we just calculated as a present value, and we find what, 7 years, right? Semi-annual, so 14. So $6,919.05. And that amount is right there. That is the answer. Questions? Okay. Let's move forward. Two debt payments, first for 800 due today, second 600 due in 9 months with interest. I think we can drop that. We're not gonna have it anyways. Next, I just don't want to lose time. Debt of 7,000 due today is to be settled by 3 equal payments due 3, 15, and 27 months. What is the size of equal payments? 11% compounded quarterly. So now 7K today, and we have 3 months payment, 15 months payment, and 27 months payment. So we have J4, 11%. So let's calculate N first. So I would do this. N is 1, right? 1 quarter, 3 months. Then let's take this. N is what? 5, right? And this N is 9. Questions on that stage? People. So 7,000. Yeah, focal date is, of course, now, right? Focal date is now. So 7,000 is X. 11 quarterly, so what is that? 0, let's bracket 0.0275. I have -1 plus X. 0.0275 minus 5 plus X. 0.0275 minus 9. So 7,000. Let's calculate that music. Okay. And again, guys, I memorize everything possible to the calculator, so it serves few purposes. Purpose number one, of course, reduces a chance of mistake, because I don't have to key back this value. So where I easily can slip on any number and punch wrong number. Right? Second thing, increases my speed calculation dramatically, because I just press two buttons, 1, 2, 3, except 10 or 11, right? $78, 3363,848 times X. 7,000 equals. So now look how fast I found the answer. 297,53856 times X. So from here, X will be 266185. That is the answer. Any questions? So let me know when you're ready. Okay, next. Amount 1,400 was invested for 71 months, maturing this much. What annual compound rate was earned? Here we have two options. Option number one, we go for annual compounded rate right away. For that, we need to find n. But let me recall your formula. I is future value over present value, 1 over n minus 1. So future value we have, present value we have, we need n, right? So what n is? Tm. N is Tm, so it is 71 over 12 times 1, because we annually, right? So 71 over 12, that's 5.916 in period. Yes, it's an inconvenient number, but guess what? Again, I memorize it. So I would be this 217736 over 1400, 1 over, and I told you this before, it's not really scientific way to do that, but we do it for our convenience, right? So 217736 divided by 1400, then exponent, recall 0, 1 over x. So yeah, minus 1, I forgot, minus 1. So I have 0.07749988. So approximately 7, what, 75%, right? So we have a second option. Second option, we find monthly rate and then convert it to effective rate, because effective rate is annually compounded, right? So I don't need to find n in this case. I just do this. 217736 over 1400. It's 1 over 71 minus 1. So by 1400 exponent 1 minus 1, I have 0.0062399681. So that's per month. And now effective rate has its own formula. What I can use here, right? So plus 1 exponent 12 minus 1. And guess what, people? I have exactly same answer. Okay, so it's up to you. First option, you have to find n, and then answer will be directly what you're looking for, annual compounded interest rate. Second option, you use 71 months and use monthly interest rate and convert it right away to annual rate, which is effective rate. Okay, questions? Let's move forward. How many months from now can payment 1,000 due 2 months ago and payment 100 due 6 months from now be settled by payment of this much if interest is such and such? So 12 months ago, $1,000. Now 6 months, $400. And instead of that, we pay 1,700 somewhere here. How come it didn't change the color? So 1746.56. Focal date is now, always. That's the equated date question. Let's do agreement by agreement. Well, we could create equation, but let's do that. So agreement 1, $1,000. 1, what is monthly, right? 0085 and 12 months. Future value formula 400 minus 6. So A1 exponent 12 times 1,000, 1106.91 plus 380.19. What I have, 1106.91 plus 380.19, 1487.10. So that's agreement 1. Agreement 2 is 1746.56 and 1.0085 negative n. Let me see if I have next page. No, I don't for some reason, but that's fine. So let me then use that cheating thing. So I will create equation like that. Right? That's my equation. Okay. So n, I know it is present value, it is future value, right? And therefore n will be, so logarithm 1746.56 over 1487.10. I use like fraction like this because I didn't have space. Logarithm 1.0085. So let's see. So I have 19.0003238. So I drop this tail because it's insignificant, And I know that because I compound monthly, I found number of months. And that's it. My time points are in months. So my answer is 19 months. That's enough. Okay. Unless they say, okay, find how many years, then you have to convert it, no other choice. Okay. Ready? Let me see how many more questions we have. We have 2 more. I think we should be all right. Okay, I'm waiting for the boat. Good to go. Okay, next. Financial obligation requires payment. Let's make a picture right away. So now 2 months, $1,000. 8 months, $3,000. 14 months, $4,000. Instead, payments 2,000 now, and I don't know, somewhere here 6,000. So focal date is today. Now let's make it. Let's separate agreements. So agreement 1. I hope I have. No. Big questions. Why I didn't put extra page? That's fine. So $1,000, 1.0075, and minus 2 plus 3,000, 1.0075 minus 8 plus 4,000, 1.0075 minus 14. So A1 75 exponent 2 negative times 1,000, 985, 17 plus 282, 5, 28, 25, 93 plus 3602, 71. So recall 985, 17 plus 28, 25, 93 plus 3602, 71, 74, 13, 81. So that is original agreement. Agreement 1, agreement 2, 2,000, it's already in focal date, plus 6,000, 1.0075 minus n. So it's time to make equation. 741381 equals 2,000 plus 6,000, 1.0075 minus n. Here I have to make format of present value formula, right? So that's why I moved 2,000 to the left, and I have this. Right? Now I have present value formula. Come on, it should be n, not some unknown creature. So now I can do, let me take orange, so n is logarithm 6,000 divided on 541381 logarithm 1.0075. So n is, okay, next times 6,000 logarithm divided, so 13, 75, 8, 8, 5, 5, 5, 5. Okay, so what is that? That is month, right? So approximately, well, 13.8 months. That's the answer. That is the answer. So let me know. We have one more question, and that's it. Okay, guys, can we continue? Okay, so Sian needs to decide how to invest his savings. He can choose between three, basically. Let's calculate effective rate for each. So J2, 395%. So F will be, so what is it? 395 over 2. It's 1.01975 squared minus 1. And here it is important to actually have all the numbers written down because they might be very close. So if you invest $100, it's okay, but if you invest 10,000, 100,000, 1 million, it's a completely different story. So J4, 392%, especially nominal rates are very close, right? So 0.098, 6.4 minus 1. 0.03978. So which one is better already? What do you say, guys? I'm on first two. The first one, yes, very good. So over 12. 0.039704733. So the first one remains the best, right? So, and no matter that last one compounds the most amount of times, nominal rates play key role here, right? So, but just what 500ths of the percent, right? And it makes a difference. So if I say, let's put 3.99%, right? This one has 3.98%, and that one, oops, that one has 3.97%. Yeah, pretty much. Now I can round it, but still. Okay, guys, on this happy note, if you don't have any questions, let me thank you for the semester, and I wish you all the best in your life. So, thank you for coming to our classes, and hopefully one day we can meet in person. And good luck on the final exam. Do your best, and that's it. Goodbye.